Hey, what's going on, guys? wukongJS here. Yesterday I spent a sleepless night debugging my move generator, trying to make it faster. And I really came up with a quite pretty important, I don't know how to call it, quite pretty important conclusion. Yeah, so a very important conclusion that I really wanted to share with you guys in this video. So let's start with a demonstration. So it runs about twice faster compared to the previous time. So you remember it was like 4 seconds with my video recording software being on, and now it's only kind of 2 seconds without this video software recording. Video recording software would be like for about 1 and 5, even 1 and 2. So it's around 1 second now, depth 3, and this sort of a position. Yeah, just didn't have to scroll that. Okay, so this is how it works now, and I just wanted to show you the improvements that I've made in order to get these improvements, and they were quite pretty surprising. I didn't really think that this sort of a changes would bring this impact on the performance. And then I will share some thoughts regarding the chess engine development progress in general. So if we have a look at the previous version of the source code that was running about kind of 2 times slower, I was making a backup copy of the current board state like this in perft, and in perf driver down below there as well, and then restore in position. So well, first I was making this inside this inside the perf function, inside the recursive process basically. And another horrible issue that was related with this sort of a code, that you see, like here I'm creating a zip copy of my board position, which is fine basically, but here I didn't actually need to create this zip copy again. So I was stringifying the already a zip copy. I was stringifying the zip copy and then parsing it again, which is absolutely weird and unnecessary. And well, I believe this line was slowing down the process the most. But the current, well, and obviously this sort of implementation is truly ugly, because it's not all, everywhere we want to make a move and take back, we need to write these horrible pieces of code. So what else? So here in perf test we have the same, but even worse that in the make move I had again again the same stuff here. So I was backing up the copy. Well, actually this now is dropped. This part is dropped as well now, assuming the current implementation. So yeah, I was really I was making anything to make it as slow as hell basically. So yeah, that's how it was going. So let me just let me show you the current implementation. So this was the code from a couple commits before the current development state on GitHub. We don't need this anymore. And here I just want to show you the current. I'm sorry, where's my backup? Oh, actually, yeah, I forgot to make it a variable as well. So I've just created this backup stack here, and now what happens in the make move? So in perft, so let's go to perft. We're not making these backups, these horrible backups anymore. We're just making the move and then taking it back, and I will now show you how this works. So you see, like I got rid of that horrible code, and that means that I no longer need to use that within my search, which I tried before, but that performed really horribly bad. Okay, so if we just go to the make move function, then we see, okay, here it is. So I'm just pushing the current board position and state variables onto this backup stack, right? Then I'm making the move, and in case if something is going wrong, say being exposed into a check, I need to take back. Yeah, here it is. I'm just taking back, right? And here is the take back function. So literally what it does, it just restores the current board position from the last element of this backup stack, and then it pops this element from the stack. So every time we're making a move, our backup array starts being like one element longer, and when we pop it back, it gets one element shorter. So literally like first in, first out, like it works in a stack. And this is the exact change that actually makes this mode generator twice faster. But again, like when I've tested the JavaScript version of wukongJS engine by Richard Olbert, I was depressed even more, because it goes I don't know, at very least 6 times faster compared to my mode generator. And this wasn't so in C. Well, so when I was testing this stuff in C, my mode generator was slower, but not that horribly slower. But in JavaScript, for some reason, I don't know, it just happens like this. So yeah, okay, just want to show you one more little improvement here. So I've simplified the move list structure. So every time we're making, yeah, so here the move list, now it's also like it's like a backup stack now. Well, we're not popping anything from the list, but anyway, so it's just a single array here, single list. And when we add and move to the move list, so let's find the add move here. I'm just pushing the object, so I've dropped keeping track of the index like it was before, because we can just simply use the move list.length attribute to get its length, basically. So we don't really need to keep track of that additional counter like we do need when we work in C with the static variables. But here it's kind of dynamic move list. That's the reason why we can actually use its length attribute to know where to stop, basically. So that's kind of it. And again, like if you just go to say perft, and so here we select move count less than move list.length instead of move list move count like it was before. And also the move itself now is referenced like move list indexed by the move count and dot move. And also as you probably already seen that I've added the score. So not only the move itself, but the associated score intended for the move ordering. Don't get confused by the score in terms of evaluation. It's not the score regarding the evaluation, it's the score regarding the move ordering, because move ordering is critical in alpha beta search. So yeah, just to show you this one more time, so we have a look at our add move here. You see, like we're pushing the score. So what probably before this line would be altering the score depending on MVV, LVA, killer history, killer moves history, heuristics, and things like that. But again, like, so the score is now the part of the move itself, and this would simplify the structure of move ordering logic, and it would allow us to make some improvements compared to the initial version of Wukong as it was implemented in C programming language. Okay guys, so this is it regarding the updates. Yeah, by the way, as always, it runs obviously it runs as the backend script, so same stuff here. So it goes even faster with the nodejs. So I just want to tell you a little story on how I was fighting with this stuff. And I was so depressed that I was really close to give up chess programming completely, because some very simple things, when you copy paste them from someone else's code and you think like you do understand how they work, and you truly believe the fact that you understand that, you feel like, okay, I just understand how it works, so I can copy paste this stuff from someone else's code and it's not a big deal. But that's good when you trying to reach a result, like absolute result. And as I was already mentioning this topic on relative versus absolute result, so the goals are completely different. Within the absolute result, you really the only thing you care about is the overall strength of your chess engine. And when it comes to relative to relative stuff. It's all about your own understanding, how deep are you into chess programming, basically. So, I've realized that lots of things that I was sure like I know how they work actually is not like that. And another little issue that I've realized that the initial patterns I was using here in this wukongJS engine, and even in my BBC chess engine as well, I was guided by the idea of trying to make the source code as easy as possible. And obviously it has a downside, so there is a trade-off between the easy to understand code and bad performance code. So what I was doing in my Wukong was probably the easiest way of how one can create a working chess engine, but it's very slow because, again, all those patterns I've been using, they're very linear, they're very simple, but they're kind of slowing down the process significantly, as I can realize this now. And if you just have a look at our make move, and just have a look at our make move function. So I'm not even talking about the take back stuff, which is not that trivial to implement, by the way. And okay, I just give you some examples. So let me just open the JavaScript version of the Wise chess engine and this make move in particular. So this is how the JavaScript version of Wise works. So here he has like move piece, add piece, and clear piece functions. So this is some sort of a refactoring of the make move function, which I'm about to involve in my engine as well, but in a slightly bit different manner, and I will now explain you why. So here is the deal. Moving piece is quite pretty self-explanatory because we just hashing the piece, and also here we just moving the piece within the piece list, which in my case is still about to get this stuff implemented. So in the make move, we have two major places. So here when we move in the rook in case of castling, so this really simplifies the code, makes it more clean. And then we only have this move piece here. So imagine like this code, clear piece, move piece. Imagine like all of this code was here, and here. So that's actually how it is in my case now. So we have a look at this. So here we move piece here, and then we go to moving the rook again here, and so on. So I'm going to separate this move piece logic into a single function. But say if I want to do the same with adding piece and clearing piece, it's not already that simple. So let's have a look at the clear piece. Let's say it's fine that we're just hashing the piece away, so taking away from the hash key, that's fine. I'm not keeping track of this material like here, but I will in case of a piece list. But anyway, where is this stuff? Piece. I'm just wondering, did I miss something? So just hold on, guys. I just want to. So we're clearing the piece. Well, let's say here. Yeah, this is it. So clearing. Let's say taking care of clearing the pawn when in peasant capture occurs. So you see, like the matter of getting piece cleared from a chessboard is done within this clear piece, but I can do it like so in my case, because to make this work, we need to make sure that we're kind of cleaning up the piece, and then we're moving the piece here. While in my implementation, which I was trying to make as linear, as simple as linear as possible and as simple as possible. So first, like conceptually, it's easier to understand. So first we make move, and then depending on the move flag, I was just handling these move flags in in the order, well, in the order of definition, or I don't know, maybe in the order of how they occur within the move integer itself. So they don't have any particular order, and the point is that if I just start trying to put this stuff into a particular order, it gets to code like this basically. And when I was watching this, when I was looking at this code, like, I don't know, kind of 2 years ago, I was already thinking like, oh my god, what's going on here? So I couldn't understand why, say, handling of captures and castling goes first, and why exactly move piece goes here, and why then goes promoted, and so on. Now I do understand this, but if I just shuffle my structure within the make move function to make it fit like this model, like it's made in Vice, that would literally be a copy paste of Vice's make move logic. So I'm gonna be making this a little bit different, trying to keep this easy to understand code at any cost. So most likely, well, move piece is trivial, so just separate this part into a single function. But when it comes to clearing the piece, I think I will still be, well, let's say in peasant. So I think still I would be making the clearing here where it occurs basically, and then I just would probably, well, within in peasant capture, it's not a big deal because in peasant doesn't rely on moving the piece, so the order doesn't matter. But when it comes to a regular capture, here, in case of the regular capture, here is the deal. So if we first make a move, that means that whatever piece was captured, it kind of disappears already. It just gets replaced with a new piece that captured that piece. And that means that if we say in this pattern, if we say just try to clear piece within the clear piece function, that means that we will clear the piece that has captured the piece that was captured. I hope you understand what I've just said. Just rewind the video and listen to this again if you didn't. So that's the issue. So we can bring this logic of clearing the piece out. So I will still need to keep this line like board, target, and so on. So another thing that is really depressing me so much. So when I was initially writing this make move function, when I was initially making all of these tutorials, I didn't really care about the fact that functions are really messy and overloaded. I was saying just like I was trying to group things together to make it easier to read, even though it's not that easy to read maybe, but again, like, so it's just a linear stuff, like we go here, then this stuff happens, then this happens, this happens, this happens, and so on. And now I realize that, I don't know, for some reason the fact of having this overloaded function actually starts depressing me as well. But again, like, in order to make it different, you know, like, it's the matter of the entire code, it's the matter of the entire concept. So to make it different, to make it in a more like human way, like programmers actually do in their engines, it's kind of the matter of dropping the entire concept of what I was doing so far, and that what makes me really depressed. Because, you know, like, if I will start following those kind of best practices, my code would be as efficient as the code of other guys who write in like relatively strong chess engines, but and quite a fun thing that, you know, like, before this, I couldn't write that code because I was too dumb. I didn't understand how they work. I didn't realize why you need to do that and things like that. Now I can do that. That's a really fun thing that by writing this weird, messy, overloaded code, I've realized how the inner workings are done basically, and now I can optimize that. But if I do that, then my engine, even despite the fact that it would be original work, still it would be like unclear how it works for beginners, as it was unclear to me before. And the thing that I think that is how my engine is different from others is that it's really easy to understand. And, you know, like, dropping this easy to understand stuff for performance, it's obviously tempting, but I'm just trying to find some sort of a compromise between having this messy overloaded code, but still the linear structure of the functions. So it's clear of what happens first, what happens then, and so on. And quite a fun thing that still, even with this sort of a bad layout, so bad refactoring, I would even say the absence of refactoring. Well, I will add some little refactoring to, again, like to separate this move p stuff and things like that. But I just, I guess you've heard that that's the matter of when you have a didactic engine, and which is not written for speed or strength, but for clarity. And if you have so you're kind of optimizing your engine to make it easier to understand. And the way all the chess engines I was writing, they are actually optimized to be as clear as possible, as simple to understand as possible. But the downside of that the performance actually suffers quite pretty significantly. And this still means that I still can work on that performance and improve that. And sometimes it gets improved in the way that I couldn't even have an idea that it would get actually improved. So from the terms of relative strength, there's really lots of job to do, regardless of whether this is the didactic engine or somewhat a real engine optimized for speed and strength. But the difference in the architecture is so different, and like I couldn't ever imagine that the difference is so different. Like I couldn't ever imagine that this can be like that. So it's totally different, really. And the matter of this difference is the linearity of the operations that are happening within the source code. So the more linear, the more straightforward things are getting done, the more easier to understand them, the slower the performance. That's an absolutely astonishing kind of conclusion I came up with this night after this sleepless night. But I really wanted to share this with you guys. So you just try to imagine what I feel, because when you let me just say the very last thing in this video, and hopefully to finish it. So the initial goal why I was picking up this didactic approach and trying to optimize my code to make it more didactic is because I couldn't understand those complicated optimizations for speed and strength in existing chess engines, even in Vice, believe it or not. So I was trying to make something easier and something that I would be able to understand, and then later to share this with others. So yeah, that was the goal. And this sort of a practice actually allowed me to realize the reasons behind those seemingly complications. They are not they are complications, but the reason behind those complications. And I don't know, I would love to call this a non-linear execution of the functions in engines optimized for strength and speed. Just to give you an idea what I mean by saying non-linear. So let's say here the make move function. So the natural thing when you're making a move, you first just try to move a piece, and then it just the board state variables depending on the move flag. So if this is the in peasant square, you just erase the pawn. If this is the double pawn push, you just set up the in peasant square. If this is the pawn promotion, you just erase the pawn, get the promoted piece, and so on and so on. If this is a castle, you just move the rook. So that's the linear stuff. But here in Vice, what he does, so first he handles in peasant, then castling. Well, also he does this. Just have a look. So he does this optionally, because actually we can have in peasant move and castling move at the same time. So this is some sort of an optimization. So this version has less branching compared to what I do here. So in my case, every time I check for in peasant, okay, and also every time I check for castling. But what he does, he actually checks for impasant, and if this is an impasant, he would never get to checking whether this is a castling. So this kind of works faster. So this expression is not getting evaluated, and that's how we can gain some sort of a speed there. So I hope that's clear. And again, like, we're not making move first. First we're handling this castling impasant. Then just here's a little bit different structure of stack, but another interesting thing to make use of these functions, like to add piece and clear piece, bearing in mind the fact that hashing is happening within this clear piece and add piece. What he does hashing in the take back, which seems to be kind of overcomplication, because the hash key is the matter of a single integer. So why not just to copy that, you might wonder. And I was thinking the same, like, why not just to copy that integer and that's it. But in that case, the entire architecture would break, because so yeah, you see, like, to make code more kind of like following the best practices, he just tries to separate the things that are happening several times, and to unify this stuff, he needs this hashing to be happening, like in both in make move and in the take back as well. So yeah, that's kind of, and again, like, we're moving piece in both the make move and take back only after this castling stuff happens. And yeah, so the order really matters. It's not just the random order. This order really matters. So yeah, and like, just I don't know. You probably don't care what I feel about this, but still, I just want to share this stuff, because like, when you start diving into these ideas of how the optimization for speed is done, you kind of start to realize that this is a totally different concept to the one that you're using, that I'm using in particular. Okay, and Wise is not the strongest, obviously not the fastest, as it doesn't have the fastest mode generator ever, and it's still quite pretty didactic. And actually, before my engines were about to come out, Vice was probably the easiest engine to understand it. It's, despite the fact it plays stronger than TSCP and it's faster than TSCP in all the respects possible, but it's easier. Its code is easier compared to the TSCP's code. It's more clear and straightforward compared to TSCP's code, to my personal eyes, at very least. And again, like, this is not the fastest way, so this can be optimized even more. And the problem is that the matter of the category you're going to optimize your engine by changes the entire architecture, the entire idea. So it's so different. I just want to say that if you start writing a Chester engine with the didactic purposes in mind, it would get incredibly difficult and literally impossible to make it actually being fast and strong, because you just pick up absolutely different approach. And when I was doing this, I didn't really realize that fact. I was thinking like, okay, so I just started with the didactic approach just to make sure that I understand what's going on under the hood, but then I could just switch to somewhat more sophisticated models to involve and so on. But it turns out that I can't, because this didactic these didactic patterns actually holding me so tight that I can't step away from them. And yeah, if I just started making that step away, I'm getting the weird engine which is not didactic anymore, because it has lost its linearity in terms of how the operations are done. And on the other hand, it's still slow and weak. So I kind of faced the issue that where I can lost both. Like it's no longer didactic and it's still very weak. So it's a piece of crap that no one needs, basically. That's the thing that has depressed me so much tonight. But fortunately, I came up with a quite pretty surprising solution, basically. And still, I don't really feel that satisfied regarding this, but I just feel like that I don't have any choice, because just let me explain. If I start, I just was thinking, why those guys that write in really strong engines never have YouTube channels, and then I've realized why this is happening. Because when you are optimizing for speed and strength, your mindset is getting completely different, and you still can explain things on how they work, but without basic understanding of how the chess engine works in general, it would be a complete total rocket science to the viewers. So then they would get amazed, but they would hardly be able to make use of that. And that's the reason why chess programmers who are creating really strong chess engine actually interacting only in on Talk Chess forum, just sharing their ideas in technical discussion room. So that's kind of how it happens. And all this entire YouTube format that I've started here, and all this chess programming channel, all these ideas I'm spreading around, all these patterns I'm using, they really fit YouTube format perfectly well, in terms of making a very complicated topic as read in a chess engine being available literally to anyone. Even for those who don't know how to code, this is still pretty available, because this you can learn how to code by creating by following the tutorial on how to make a chess engine. That's the exact way how I got into the programming and eventually became a freelancer, believe it or not. So yeah, but on the other hand, I really can't. Now I'm kind of tied up with this didactic purposes, and I can no longer resist of making something else. So like if you might wonder what stops me from starting, let's say, a completely new chess engine from scratch, and trying to optimize it for strength and speed. In that case, I will need to drop the YouTube, because in that case, when you dive in really deep in there, you kind of stop. You kind of losing that interaction with your community, because it gets really complicated, and people don't like to watch something that they can understand, and the reason why people following is because they understand what is happening in the video, because they feel kind of the part of it, and they just follow because that's interesting, that's something, But in case if really kind of going for optimizing engines for speed and strength, it's not. So you just might wonder, why some sort of a stockfish author is not creating their YouTube channels and not making videos like how to make the strongest chess engine in the world, which would literally have millions of views, right? But they don't do it because I literally won't get the million of views, because it's too complicated. It's very specific. It's something like, if I don't know, say that rocket science. You imagine the rocket science on YouTube, the real rocket science, not as comparing it to something, but the real rocket science. Let's take a rocket, how it flies to space, how it lands the moon or Mars. That's complicated. So you really need to know. Yeah, you really need to have lots of knowledge, and I don't know. You feel like you just brick is crashing through your head, and you don't understand anything after that. So that's it. So YouTube assumes an easy to pick up approach, easy to understand one, and that's the exact thing that I'm doing here. And that's the limitation at the same time, because I really can't make this didactic stuff kind of faster, right? And the very last thing is that I was actually concerned regarding the fact that I was thinking, believe it or not, I was thinking that if I start improving my engine, it stops being didactic. That was my concern, believe it or not. But it's not true, because I realized that, like those initial patterns and that initial architecture you're bringing into your chess engine, it goes until the very end. And no matter how you improve the code, still, it's kind of like, it's not gonna change. It's still, it would be didactic until the dying day. So no matter how you optimize it, it still is gonna be a didactic engine. So these are two completely different patterns, believe it or not. The didactic optimization for being didactic, for being easy to understand, and the optimization for being fast and strong. And it doesn't matter if this regards to mood generator or search itself. It doesn't really matter that much. So, like such a trivial thing that these two kind of approaches are different, that I thought I knew everything about, turns out to be very insightful to me personally. So I really wanted to share these thoughts with you guys. So at the very end, what am I supposed to be doing next? So I've realized that my chess engine Wukong is doomed to be weak and slow, but despite this fact, I still can improve it, believe it or not, and I still can have some relative speed improvements, and later maybe some strength improvements as well, because there's even within the didactic patterns, still there are lots of there is a big field for improvements, and it's more like, I don't even call it a coding exercise, because quite often I still sacrifice the good coding habits, and still the code might be messy and overloaded with an overloaded functions. And it's really hard to pick up some particular thread that you're following, that so where exactly to improve. Basically, it's really hard to pick up that thread. So some guys can just you don't care about if your engine gets stronger, but you're just trying to make your code cleaner. So that's one of the approach. And another approach, maybe not caring about how code looks like, but trying to make the most performance of this didactic approach, let's say like this. Because again, like if I'm ever about to step into optimizations for speed and strength, it would no longer be covered on YouTube, because that's a completely different story, and I don't really want that to happen, because I think that doesn't make sense, because there are really lots of good programmers who make fast and strong engines, and I'm too dumb to compete with them, and then I hate competitions, to be honest. But no one is doing this on YouTube, so I think maybe here I can just bring more use to chess programming world. Well, okay guys, this is it from my side. I hope to see you in the next video. Until that time, and take care.